200 tickets in 4 hours, dark mode just broke half your UI. The culprit: AI-generated components with hard-coded colors that looked fine in light mode. Partial pre-rendering, PPR, is an experimental feature in Next.js 14 and 15. It requires experimental, PPR equals true in Next. Config.js and is not yet recommended for production unless you are prepared for breaking changes in minor releases. Always pin your Next.js version and test PPR thoroughly before deploying. The article mentions benchmarks but does not provide a concrete script. Use this Next.js root segment config to compare TTFB and server load between PPR and streaming. Run with next build and a next start and measure with curl w @time total \n o/dev/null_s. PPR caches the static shell at the edge. If your dynamic content changes frequently, ensure you have a proper cache invalidation strategy, e.g., revalidate or on-demand revalidation. Without it, users may see stale static shells while dynamic content updates, a common pitfall in production. Let's break down partial pre-rendering versus streaming Next.js benchmarks, how it works, and the exact mistake behind that failure. In this lesson, we'll dissect a real-world failure mode of AI-generated UI components, hard-coded colors breaking dark mode in shadcn-based projects. You'll learn how to generate components that respect your design tokens and how to fix the 5 most common AI mistakes. Shadcn is a collection of reusable React components that ship as source code you own, built on Radix UI primitives and Tailwind CSS. Its core value proposition is that components use CSS variables for theming, allowing you to swap color tokens globally for dark mode, branding, or accessibility. The theming contract is simple. CSS variables define colors, and dark mode swaps those variable values. Components must reference these variables. If a component uses hard-coded hex values, it silently breaks the entire theming system. The workflow combines V0 for generative scaffolding and Cursor for contextual refinement. V0 produces styled React component shells from structured text prompts in about 2 minutes. Cursor adapts that output to your project's design tokens, hooks, and patterns in 8–10 minutes. Total: 10–12 minutes per component versus 25–35 minutes for manual creation. The foundation is the component specification document. For each component, define name, core function, key props, variant options, required states, and the shadcn/UI primitives it should use. The do not generate field prevents AI from embedding logic that belongs in hooks. Here's an example spec for a metric card component. It defines 3 props, 1 variant, a loading state, and the shadcn primitives to use. The do not generate field tells the AI to avoid embedding data fetching logic. The prompt template translates directly from the component spec. Every field in the spec maps to a section of the prompt. Critical elements: explicit shadcn/UI primitive names, semantic token instruction, state requirements, and the separation instruction. Here's the filled-in prompt for metric card. Note the explicit style rules: semantic tailwind tokens only, and no hard-coded color classes. These 2 lines alone prevent the dark mode drift incident. The V0 output is functional and visually correct in light mode, but it fails in dark mode. It uses hard-coded colors like BG white and text gray 500, default exports, broad union types, and direct import paths instead of barrel exports. Notice the hard-coded BG white and border gray 200 classes. These will not adapt to dark mode. Also note the default export and broad string types for trend and size. Hard-coded color classes like BG white and text gray 500 break dark mode completely. In dark mode, the background becomes dark, but the text stays gray, or worse, white text on white background becomes invisible. After applying the 5 cursor commands, the component uses semantic tokens like BG card and text muted foreground, has strict union types, named exports, and barrel imports. It now works correctly in both light and dark mode. The refined component uses barrel imports from @company/UI, strict union types for trend and size, and a named export. The loading state now uses the card wrapper, so the skeleton matches the final dimensions. The cursor refinement phase is 5 targeted commands run in sequence. Each command fixes one consistent failure pattern that V0 produces. Running all 5 takes 8–10 minutes and fixes 90% of issues. These are the exact CMD+K commands to run in cursor. Each command is scoped to one failure pattern. Running them in sequence transforms the raw V0 output into a production-ready component. This is the same issue we highlighted at the start. Here's exactly why that happened. The AI generated components with hard-coded Tailwind color classes like BG-White and text gray 900. When the dark mode toggle switched the CSS variables, those hard-coded classes didn't change. The result: white text on white backgrounds across 18 components. AI-generated components used hard-coded color values like BG-White and text gray instead of semantic tokens, causing white text on white backgrounds in dark mode. The fix replaces all hard-coded colors with CSS variable tokens. The fix was to replace every hard-coded color class with semantic tokens like BG-card and text-card foreground. We ran a grep for BG-White, text gray, etc., and fixed each instance. After the fix, dark mode worked correctly because the tokens adapt to the current theme. AI-generated components often have on-click handlers without corresponding on-keydown or role attributes. This makes the component inaccessible to keyboard users. Always add keyboard handlers and ARIA labels. To debug hard-coded colors, run a grep for common hard-coded classes. For accessibility, use AxGly against your storybook stories. Always toggle dark mode manually and inspect every state. Let's run through some common interview questions. How does shadcn handle theming? Uses CSS variables that can be swapped globally for dark mode. What is the most common AI generation mistake? Hard-coded color classes instead of semantic tokens. How do you prevent component sprawl? Write specs first, ask, can this be a variant? Before generating. And a few frequently asked questions. Can I use AI to generate any component? No, only standard presentational components with clear shadcn primitives. How long does the full workflow take? 15–17 minutes per component, including quality gates. What is the most important quality gate? Design token compliance. Hard-coded colors break dark mode. Let's recap the key takeaways. Write specs before generating any components. Use semantic tokens, never hard-coded colors. Run 5 cursor commands in sequence. Apply 4 quality gates before merging. Ready to go deeper? Up next, Introduction to JavaScript, then variables in JavaScript, then data types in JavaScript, and operators in JavaScript. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.